Today we will learn how to derive the output equation of a DC machine. First of all, let's see what is the output equation. The output equation of a DC machine is related to the power developed by the armature. So we have to keep in mind that output equation is has nothing to do with the output power. It has a relation only with the power developed in armature of the DC machine and the iron and friction losses and windage losses. And this output equation is very much helpful for designing electrical machine, DC machine. Before starting the derivation, we will define some terms. First one is PA, that is power developed in armature in kilowatt. Capital P is the output power of machine in kilowatt. EA, or simply E, is the EMF generated in armature, that is volt, unit is volt. And small letter p is the number of poles, and phi is the flux per pole. It's not the flux, it's the flux per pole in armature periphery. It should be in Weber. And IA is the armature current. I suffix Z is the current through each conductor. So usually it is calculated as armature current divided by number of parallel paths. And A is the where A is the number of parallel paths. Next, Z is the total number of armature conductors. N is the speed of the machine in revolutions per minute, RPM. Small letter n is the speed in RPS. So it is calculated like this: speed in RPS, small letter n is equal to speed in RPM divided by 60. So it will become in RPS. Then capital D is the armature diameter, L armature core length, tau is the pole pitch. We have already discussed this, and the equation is pi d by p. It's the pole pitch, that is distance between adjacent poles. And AC is the specific electric loading, that is ZIZ by pi d. And B average is the specific magnetic loading in Weber per meter square, and that is P5 by pi dl. Next, we'll start the derivation. In a DC machine, the power developed in armature, that is the armature power, PA is equal to EMF or voltage induced in the armature into armature current into 10 raised to minus 3 to convert it into kilowatt. So E into IA into 10 raised to minus 3. But we know that in a DC machine, E is equal to phi Zn by 60 into P by A. And we are converting this n by 60 as small letter n, where small letter n is the speed in RPS. So phi Z small letter n into P by A is the EMF induced in the armature. So we can write PA is equal to phi Z n by P by A into IA into 10 raised to minus 3. Now let's rearrange this equation like this. So here we have taken phi and P together like this, and N is directly written here. Now Z, IA and A are written together. So this equation is same, but we have rearranged the terms. But in this equation, IA by A is equal to IZ, that is current through conductor. Current per parallel path is equal to current through a conductor. But we know that the specific magnetic loading B average is equal to P5 by pi dl. So we can write P5 is equal to B average into pi dl. So instead of P5 we can substitute. Similarly, AC is equal to ZIZ by pi d. So ZIZ is equal to AC into pi d. So instead of ZIZ, this is IZ. Instead of ZIZ, we can write AC into pi d. So we can replace two terms, this one and this one. So remaining only n will be there. So it will be like this: PA is equal to B average pi dl instead of P phi, and AC into pi d instead of ZIZ, and n directly written into 10 raised to minus 3. Now we will again rearrange these terms. There are two pi's and d. There are two terms of d and two terms of pi. So we have to rearrange this. Finally, the equation becomes like this: PA is equal to pi square B average AC into 10 raised to minus 3 into d square ln, this much of kilowatt. Now again we are rewriting this equation like this, where PA is equal to C0 or CO into d square ln. So this is CO, where CO is equal to pi square B average AC into 10 raised to minus 3, and that is known as the output coefficient. So sometimes in university exams you will have to calculate the output coefficient or write the expression for output coefficient. So we have to keep in mind that CO, that is output coefficient, is equal to pi square B average AC into 10 raised to minus 3. Thank you.